Ever wondered how AI tackles problems that feel impossibly complex? Like literally impossible. Imagine a math puzzle that loops 2016 times, starting with the number 2. It sounds like a nightmare, but AI doesn't just solve it, it understands it. Let's break down how this works and why it's a game changer for AI reasoning. Here's the puzzle. You start with 2, then apply a rule over and over. The rule: take the current number, subtract 1 divided by itself. So 2 becomes 2, 2 equals 1.5. Then 1.5 becomes 1.5, 115 approximately 1.166, and so on. Do this 2016 times, and what do you get? At first glance, it's a chaotic mess. But AI sees patterns where we see chaos. This is a recursive sequence, and it's hiding a secret. The AI doesn't just brute force the calculation, it looks for a shortcut. Let's walk through its thought process. First, it runs a simple Python script to simulate the first 10 steps. The numbers start at 2, then 1.5, then 1.666, and slowly they start to stabilize. After 10 iterations. After 100, tilde 1, 0, 0, 1. After 1000, something. It's approaching 1, but never quite reaching it. The AI realizes this is a convergent sequence, a mathematical concept where values get closer and closer to a specific number. But how do you find that exact number without running 2016 steps? Here is where the magic happens. The AI sets up an equation. If the sequence converges to a value x, then applying the rule once more shouldn't change it. So x equals 2, 1x. Solving this gives a quadratic equation. x2, 2x plus 1 equals 0, which factors to x, 1, 2 equals 0. That means x equals 1. The sequence approaches 1 but never actually hits it. But wait. The problem asks for relatively prime positive integers m and n, such that the final result is mn. If the answer is 1, that's 1, 1, so m plus n equals 2. But the AI catches a contradiction. The code simulations show the value is very close to 1, but not exactly 1. What's going on? The AI realizes the trick. This isn't just a simple sequence. It's a nested radical, like an infinite loop of operations. The true solution requires a different approach. Instead of brute forcing, the AI rewrites the equation, recognizing it's a fixed point problem. The answer isn't 1, but a value that approaches 1 infinitely. This is why models like Decode 1 are revolutionary. They don't just follow rules, they adapt, question, and refine their strategies. By combining symbolic reasoning with numerical simulation, they uncover hidden mathematical truths. This isn't just about solving a puzzle, it's about redefining how AI interacts with complex, recursive problems. So next time you face a problem that feels impossible, remember, AI isn't just calculating, it's thinking. And with tools like Decode 1, the boundaries of what's solvable are expanding faster than ever. Stay curious and keep exploring the frontier of AI reasoning.